There has been no better time to learn cloud technologies than it is now. And in today's episode, I will explain what is cloud. We will then understand how the cloud is built and how it works on a very high level. I will also explain that why cloud is even needed in the very first place. And then briefly, I will show you what are the different cloud providers in the market. Once we have understood the what, why and how behind the cloud, we will then take the next step of understanding the most commonly used cloud terms. And in today's episode, we are going to understand the very important concept of IaaS, which is infrastructure as a service, PaaS, which is platform as a service, SaaS, which is software as a service. We will understand what are they, and we will also understand the differences between them. And during today's presentation, I will also explain what are virtual machines. I will make sure that you understand all the cloud concepts and make a great job opportunity for yourself. To understand what is cloud, let's start with something we all know and understand. Suppose you have a laptop. What are the basic components of a laptop? If I take a bare metal laptop, we would need CPU, some memory and a network interface card to start with. Now friends, all of these components such as CPU, memory and network interface card comes together to make a basic laptop. Of course, this is an oversimplified example. There is a lot more that goes into building a laptop, but let's keep it simple for now. Now let's take a slightly more complex example of data center. So let's start building a data center. Suppose you or your company is building an on-premises data center. By on-premises, I mean a data center that is owned and maintained by the company, generally within their premises. Similar to building a simple laptop, you would need CPU or computing power to build a data center as well, but of course on a much larger scale. Along with that, you would also need large storage devices, and on top of this raw computing power and storage, you would need multiple virtual machines which could be running on Windows or Linux or any other operating system of choice. Now here comes our first very important term, virtual machines. Let's first understand what are virtual machines and then we will come back to the data center. Virtual machines are a very important concept no matter which cloud are you working with, be it Azure, AWS or GCP. Virtual machine is used everywhere, and if I say virtualization is the core technologies behind cloud, it won't be an exaggeration. Now friends, virtual machine is a compute resource that uses software instead of physical computer to run programs and deploy apps. A virtual machine is basically a computer file, usually called an image, that behaves just like a real computer. It can totally replicate your entire computer experience. Virtual machines allow a business to run an operating system that behaves like completely separate computer. Just keep in mind that virtual machines are virtualized instance of a computer that can perform almost all of the same functions as a computer, including running applications and operating system. The most important word here to note is virtualized instance. Coming back to our data center example, until now we have mostly set up our hardware layer. For now, we already have compute and storage devices. We also have virtual machines and operating system in place. Now the next level in building a data center is of course to bring a software layer. And this brings us to the first software component. Let's build a database. So let's say we install a database to store our business master or any other transactional data. And then on top of this database, we would need a business application that will be the front end for the business application users that provides an interface to deal with the database. And friends, not to forget that everything is connected via some kind of network. The network could be intranet or internet, so that all your users are connected to the database and the business application. And of course, they can share files and data amongst each other. So friends, this is how a data center is built. Once again, I want to highlight that this is an oversimplified example and is kept as this is a beginner course. Of course, in real life, there are many more components needed to build a data center, but I am sure that you got the gist. So life was good with data centers. Companies could build big data centers, install all the components that they need, and then wait for the business to flourish, right? Well, that's not so true. So what are the challenges with data centers? The biggest problem with on-premise data center is the cost. CapEx, or also known as capital expenditure. Just understand that CapEx is the upfront one-time massive expenditure that any company has to incur to build a data center. It will take a lot of money, time, and efforts to set up a data center. Moreover, it's not a one-time affair. Your company will be responsible for the system maintenance and administration for the entire lifespan of the data center. The second biggest challenge with on-premise data center is the maintenance cost. As I just mentioned, that not only upfront cost, but the maintenance cost of the data centers is also a big challenge. The companies have to keep trained IT professionals who will be responsible for maintaining the servers, carrying out the routine maintenance services such as installing and updating security software. And friends, you need to also understand that this was still okay for the IT companies, but what about other businesses? Suppose your company is in the business of selling cakes and cookies. Now, even if your company's specialty is making cakes and cookies, they still have to hire trained IT people to create and maintain data center. This is a huge resource diversion from the main business. A lot of money and time gets wasted. Moving on, we have limited scalability. On-premises solutions have an upper limit of capacity. Once you have built the data center, it will be really hard to scale up in case your business grows. In fact, the vice versa is also true. Till the time your company's business is not in full scale, you will be wasting a lot of data center resources, which of course means monetary loss. Then the fourth biggest limitation of on-premises data centers is less accessibility. On-premises solutions typically cannot accommodate a distributed workforce. Besides this, adherence to the industry compliance is also a big challenge for the on-premise data center. It's not very easy to implement and comply with the regulations in case your company is in industries such as finance or healthcare. The responsibility to abide by governing regulations is on your company, and any miss can land your company in big regulatory issues. And of course, not to forget the environmental issues. A report says that data centers produce half of the world's carbon dioxide emissions, and this is increasing each day. The increasing energy consumptions and CO2 emissions of data centers have become an unavoidable social responsibilities of all the enterprises. Besides these challenges that I have listed, there could be many more other challenges. Can you think of any other challenges with data centers? So please let me know, what do you think are the biggest challenges of data centers in the comment section below. So friends, what do you think is the way out, or is there any way out of all these challenges? Yes, of course, there is a way out. Cloud technologies come to the rescue in all these kind of problems. So what exactly are cloud technologies? I hope you remember our laptop and data center building example that we just covered in the previous slides. In those examples, we learned that we need basic components like CPU, storage, and network to build a data center or a basic laptop. But in case of cloud technologies, unlike a laptop or a data center where all the hardware and softwares reside in a single machine or a company-owned data center, you can think cloud technologies as if all these hardware and software components are hosted on someone else's data center like Microsoft Azure, Amazon AWS, or Google GCP. And all you have to do is use all these resources over the internet. Now let's check out the official Microsoft documentation, which tells us what is cloud computing. And here you can see that Microsoft says that, simply put, cloud computing is delivery of computing services including servers, storage, database, networking, software, analytics, and intelligence over the internet, which is called cloud, to offer faster innovation, flexible resources, and economics of scale. And as a user, you typically pay only for the cloud services that you use, helping you lower your operating costs, run your infrastructure more efficiently, and scale as your business needs change. So once again, let me summarize. Cloud computing is when, instead of using your data centers, you use computing resources such as servers, storage, databases, networking, or other software over the internet. And friends, please keep in mind that unlike data centers where you own all these resources, on the cloud, however, these resources are owned by the cloud providers. As a user, you just use these resources over the internet and you pay for the extent you have used them. And this kind of expenditure is also known as operational cost. And there is one more linked concept with this, which is called pay as you go. We will learn all about these concepts in the upcoming subsequent parts. Here you can see that we have the list of all the benefits of cloud computing. The biggest benefit is cost. Cloud computing eliminates the capital expense of buying hardware and software and setting up and running on-site data centers, rack of servers, the round-the-clock electricity for power and cooling, and the IT experts for managing infrastructure. Besides this, you can also read the other benefits. We have speed, we have global scale, we have productivity, then we have performance, reliability, and security. So are there any disadvantages of using cloud technologies? Well, like any other thing, cloud also has some disadvantages. Let's check them out. The first major disadvantage of using cloud technologies is its dependency on internet connection. As we saw in the definition of cloud, resources on cloud technologies are accessible using the internet. And of course, when there is no internet in your place, or maybe a slow internet connection, or maybe the path to the internet cloud provider is in trouble, in this case, you won't be able to access the cloud services. The second disadvantage of using cloud technologies is privacy and compliance. When you use cloud resources to store your data is now no longer on your physical storage, but on cloud storage. This may be an area of concern for certain type of application. And then we have security. Secrecy and security are amongst the most doubtful things in cloud computing. Having said that, I'm not saying that cloud applications are not secure. They are very, very secure applications. In fact, in some cases, I can say that they are even more secure than the on-premises application. However, because it's a shared responsibility, it sometimes confuses many users, and this confusion in the implementation of security in the cloud application can result in security breaches. So friends, definitely there are some disadvantages of using cloud technologies, but the advantages of using cloud technologies weigh much more, and that's why no wonder world's biggest companies are moving their solution to cloud technologies. Until now in this session, we have understood what exactly is cloud, why do we need it, how the cloud is built, what are the advantages and disadvantages of using cloud technologies, and now let's very quickly check what are the different cloud providers. So friends, here is the list of top 5 cloud providers available in the market today. The first one in the list is Amazon AWS, followed by Microsoft Azure, and then we have Google GCP, Alibaba Cloud, and Salesforce. Besides these top 5, it's worth mentioning about Dell Cloud, IBM Cloud, DigitalOcean, Adobe Cloud, and Dropbox. Now let's check out what are the type of cloud services based on computing models. The first cloud service based on computing models is infrastructure as a service, or IaaS. And as you can read here, infrastructure as a service enables one to build and control their own servers, storage facilities, networks, and operating systems. You can say that it is one step away from on-premises infrastructure, and it's a pay-as-you-go service where a third party provides you with infrastructure services like storage and virtualization as you need them via a cloud through the internet. And then we have platform as a service. So PaaS refers to the cloud computing services that supply an on-demand environment for developing, testing, delivering, and managing software applications. And you can say that it is another step further from full on-premises infrastructure management. And friends, PaaS is primarily useful for the developers and programmers to develop, run, and manage their own apps without having to build and maintain infrastructure or platform usually associated with the process. And then the third type of computing model is SaaS, or software as a service. So software as a service, also known as cloud application service, and this is a method for delivering software application over the internet. Cloud providers host and manage the software application and the underlying infrastructure and handle any maintenance like software upgrades and security patching. Friends, always remember these 3 quick tips. When you are starting from on-premises data center, you first move to IaaS, or infrastructure as a service, and post that the normal progression is towards PaaS, or platform as a service. So you build on PaaS and then eventually you start to use software as a service. Now let me give you example of each of these cloud computing models so that you understand them better. To start with, we have infrastructure as a service, and virtual machine is the best example for infrastructure as a service. Then the example for PaaS, or platform as a service, is servers, storage, and networking. And then we have SaaS, and the example of SaaS is email, calendaring, or office tools such as Office 365. Quick summary, today we learned what is cloud, how the cloud is built, and why do we need cloud technologies. We then understood different cloud providers, and we also learned the concept of IaaS, PaaS, and SaaS, and understood what are virtual machines.
And yes, do not forget to subscribe to the Tech Blackboard YouTube channel for more such career building videos both on Microsoft Azure and Amazon AWS.